Hi everyone, welcome to our second lecture. In this lecture, we are going to talk about the basic concepts related to machine learning, and we are also going to define what is machine learning. Okay, so machine learning is a science of programming computers so that they can learn from data, or you can say machine learning is an approach to learn complex patterns from existing data and use these patterns to make prediction on unseen data. So let me give you an example of why we use machine learning. So you must have seen some of your emails automatically being sent to spam folders. Using traditional programming, we can only filter emails based on rules coded in the program. Let's say you wrote the program to mark 100% authentic product as spam. So this code will only mark such emails as spam which contain this phrase. But what if you want to mark other emails as spam as well? In that case, we will have to update the code or write a new one. In problems like this, machine learning is very helpful as it allows us to simply train the model based on some instances of spam and some useful emails. It will learn the pattern from the data and filter out spam emails from useful ones, no matter what spammers are trying to send. It will keep updating and learning patterns to filter the emails based on future data available with us. This is a very useful example of machine learning, and you can say there are other useful examples as well. So what kind of problems can be solved with the help of machine learning? Well, machine learning is mostly helpful for problems that are either too complex for traditional programming approaches or have no known algorithms. For example, email spam protection or voice recognition with the traditional programming approach is more complex, whereas with ML the program is shorter, easier to maintain and likely to be more accurate than the former approach. Additionally, machine learning models are adaptable to new data and can offer us deeper insight into the data or problems at hand based on the learned patterns. Now let's look at what is a labeled training set. Okay, so there are different types of problems that we work with in machine learning. Some of the data sets that we work with contain the solution already in it, whereas some data sets do not contain the solution. And the dataset that contain the solution are called labeled training set. So when we feed the training set, it contains the label already, whereas some training set do not contain the solutions in the dataset. We call them unlabeled data or unlabeled data sets. So you can see this from the picture here that there is this labeled data here, and this is unlabeled on the right side. So these are a few things that you are going to learn in future as well. Now let's see what are the types of machine learning systems. Depending on the amount and the type of supervision during the training phase, ML systems can be classified as supervised learning problems, unsupervised learning problems, semi-supervised learning problems, reinforcement learning problems. So basically these are four types of machine learning systems. We are only going to cover three types, that is supervised learning, unsupervised learning, semi-supervised learning. So we are going to cover these three problems. We are not going to cover reinforcement learning in this course as this is a completely different topic. So basically we are going to work with these three problems only. So let's see what is supervised learning. In supervised learning, the training data passed to the model contains solutions. So you can say we already talked about the concept of training set that contain labels. So basically in the supervised learning problems we deal with the data that contain the label already. So these are a few algorithms which are part of supervised learning: k-nearest neighbors, linear regression, logistic regression, support vector machines, decision trees and random forest, and the neural networks. Now let's see what is unsupervised learning. In unsupervised learning, the training data passed to the models do not contain the solution. So this is basically the opposite of supervised learning. And these are a few problems where we use unsupervised learning. In problems of clustering, anomaly detection and novelty detection, visualization and dimensionality reduction, association rule learning. And there are a few models that we use: k-mean, dbscan, hierarchical cluster analysis, one class, SVM, isolation forest, principal component analysis, etc. You don't need to get confused by reading the names, or you do not have to remember the names of these particular models. We'll cover these models one by one in future. So just don't be bothered, or don't just not be scared just by seeing the name of these models. Now let's see what is semi-supervised learning. So in semi-supervised learning, we have majority of the data that do not contain the solution, but a few of the data contain the solution. So you can say it is kind of combination of both supervised and and unsupervised learning. So basically in this, the models are trained on a lot of unlabeled data and a very few labeled data. We are going to work with the problems and then it will become more clear. Now let's see what is reinforcement learning. Again, this is out of the context, but still you can say in reinforcement learning we teach machines some things like how to play game, how to walk, etc., using some kind of reward function, or you can say some penalty. So it involves the idea of agents, reward, environment, policy and penalties. Agents are learning system, the models. They learn using the best strategy called policy to get the most rewards or penalties, negative rewards, within their environment, such as game screens, etc. You must have heard about Google's DeepMind AlphaGo, which defeated the world Go champion in 2017. And I think there is a documentary about that as well. You should go and do some research about reinforcement learning and maybe watch that documentary, because that is an amazing documentary. So yeah, basically go and research more about reinforcement learning if you're interested, because this is also an interesting field, and you can say they call it the beast of the AI. Now let's see what is generalization. So generalization is your model's ability to adapt properly to new, previously unseen data drawn from the same distribution as the one used to create the model. That means how well the model works on unseen data. So when we are training the model on our training data, the model has already seen that data, but now it's time to do some prediction to check whether our model is performing on unseen data or not. If the model is performing and how well the model is performing, that thing is called generalization, like how well the model is actually making the prediction. So that is called generalization. Now let's see what is model parameters and model hyperparameters. So in machine learning, parameters are variables that are learned from data during the training process to make predictions. They are updated to minimize the difference between the predicted values and the actual values. So you can say these are some things, variables learned from the data. Whereas in hyperparameter, what happens is these are some, you can say, things that are external to the models and they are not estimated from the data. So these are, you can say, these are controlled by the person who is training the model. So whenever you are dealing with something that you are controlling, some variables that you are controlling about the model, consider that as hyperparameter. And chances are that you won't have to deal with parameters manually on your own, because these are already estimated by the models using the data that you are training the model on. Now let's see what is training set, test set and validation set. So whenever we are working with machine learning problem, we are offered with a data set. We divide the data set into training set and test set. Training set, you can say, is a subset which is used to train the model, whereas test set is a subset which is used to evaluate the trained model. Whereas the validation set, you can say, is a portion of the training set. You can say when we are testing the same model with different hyperparameters, we hold out a fraction of the training data to test different models. Different model means same model using different hyperparameters, so that we can select the best model. This set is called validation set or dev set or development set. The model is then trained on the full training set to get the final model. If the validation set is too small or too large, perform cross validation to choose the best model, otherwise you will end up using the wrong model. So what I am trying to say is, the concept of validation set is quite difficult, not difficult, like it will get more clear with practice. Maybe once we are working with the actual problem, you will be able to understand what exactly I am trying to say, what exactly is validation set. So you can say validation set is simply used to evaluate the same model on different hyperparameters and select the best performing model. Now what is generalization error? Error rate on new cases, test sets, is called generalization error. So let's say you train the model and now it's time to make the prediction. and you want to see whether my model is able to make the actual prediction or not. So whatever error that you are getting on the test set, that is called generalization error. Now let's see what is sampling bias. So you can say sampling bias occurs when the sample does not accurately represent the characteristics of the population from which it was drawn. So let's say you want to make some analysis on a group of 1000 people, but you only selected 100 people. So you need to select 100 people in such a manner so that 100 people are representative of the entire population, of the entire 1000 people. So you need to make sure that your data is actually accurate and it is actually processed in a manner so that it can give you the better result, better outcome. If you are feeding your machine learning model with bad data, it won't produce a good outcome. So you need to ensure that your data is correct, and you need to make sure that whatever result you are expecting, you need to feed the data accordingly. Now let's see what is overfitting and underfitting. So these two concepts are very important for machine learning. We'll definitely come back to these two concepts in future because there are more to these concepts than these two definitions. So overfitting is if the training error is low but generalization error is high, then model is said to be overfitting the training data. Overfitting means that the model performance is good on training data, whereas it does not generalize well on the test data. And you can say underfitting happens when the model is too simple to learn the underlying structure of the data. So like model is not learning anything from the data. And in overfitting, actually you can say the model performed well on training data, but it did not perform well on the test set. So now let's see what are the main challenges of machine learning. So the main challenges can be insufficient quantity of training data, non-representative training data, poor quality data, irrelevant features. So what you can do to fix these problems? Well, if you have insufficient quantity of training data, try to add more data for better learning. If you have non-representative training data, try to add more data for better generalization. Always consider sampling bias and sampling noise. If you have poor quality data, try to spend more time on your data and try to do some cleaning. Irrelevant features. So try to add better features using feature engineering. So let me explain you what is feature and feature engineering. So basically feature is, you can say, the attributes, and whenever you're offered with data set, you must have seen there are various columns representing the height, weight, etc. of that particular data. Whatever data you are offered with, there will be different features. So let's say you have the data of people, and we have some features like height, weight, etc. So these things are called, these attributes are called features. And feature engineering, you can say, is the process of doing some manipulation over features and finding out the best feature and doing some changes and seeing mixing up two or more features and seeing which one we can use for the model for better performance. We'll talk about feature engineering in future lectures as well when we are working with the actual model, because feature engineering is very important for machine learning. And definitely you can say we'll come back to so many topics that we have covered in this course, in this particular lecture, and we'll talk about those topics in more detail, and you will get more clarity once you're working on the actual problem. Also, features and attributes are used interchangeably, so don't get confused what is feature and what is attributes, because these are columns representing the data set. And whenever you have the data set, one row is called the instance, so don't get confused in that as well. Now let's see what is free-lunch theorem. So the free-lunch theorem says there is no guarantee for any model to be right fit for your data. You can either evaluate all the available models, or you can save your time and make some assumption about the data and evaluate them over some reasonable models for your problems. That means there are so many available models out there, and you can evaluate all the models. You can try all the models and see which model is performing best on your data, but you don't need to do that. What you need to do instead is make some assumption about the data, and first of all make sure what kind of problem I am working with and what kind of outcome I am looking for. So depending on the kind of problem and the kind of data, just try to make some assumption and try to decide which kind of model is best suitable for my problem, and that way you will be able to save a huge amount of time. That's all. So in this lecture, we have covered the basic concepts related to machine learning and the definition of machine learning. In future lectures also we'll come back to these concepts and you will get more clarity because we'll be working with practical problems. That way you'll get a better understanding of what exactly these terms are. And don't forget to read the blog post that I have written about these concepts, the link to which is mentioned in the description below. Additionally, don't forget to join our Discord community, ask your questions there. You can ask your question in the comment section below, but as I mentioned previously that we won't be able to see your questions and maybe other members won't be able to discover the questions. So it's better to ask in the Discord community because your questions will be archived there and members can also discover the answers. And stay tuned for the future lectures. Don't worry about these concepts. We'll get back to these concepts once again. Thank you so much for watching this video. Make sure to subscribe to this channel and join our Discord server.